Welcome to Radio Astronomy, the podcast from the makers of BBC Sky at Night magazine. Today we're travelling down to the National Astronomy Meeting being held this year in Cardiff. It's an annual event where astronomers from around the country gather together to talk about their various different astronomical endeavours. Hello, I'm at the National Astronomy Meeting here in Cardiff today, and today I'm talking to Alex Andersson, who gave a talk about discovering radio transients using humans and machines. That sounds very exciting. One of the particularly exciting things was that you use a data set from the particularly evocatively named ThunderKAT.
Yeah.
So could you tell us what exactly is ThunderKAT and what were you looking for?
Yeah, sure. So ThunderKAT in what we do is a survey taken from the MeerKAT telescope, and ThunderKAT as a name stands for a slightly sort of tortured acronym for the Hunt for Dynamic and Explosive Radio Transients with MeerKAT. So really, rolls off the tongue. But I think it was inspired by one of the PIs of the project. Their husband was a big fan of the ThunderKAT comic books, and so I think it's kind of been forced in there. But yeah, I think it's a good name. And the whole aim of it is to look for different kinds of things that sort of go bump in the night with radio telescopes, basically. So we look for all kinds of systems both in our galaxy and out of our galaxy, and my work is on searching for interesting transient things that we didn't necessarily know about beforehand.
So when you say a transient thing, what do you actually mean?
Yeah, it's a bit of a catch-all, right? So just a radio transient in this case is just something that we see, when we look in 1 week with our radio telescopes, it's not there, and then look a few weeks later and it's suddenly there. So this could be things like nearby stars that sort of flare like our sun does. This could be distant galaxies that are sort of scintillating a little bit, and just about anything in between. So it's a pretty general method that doesn't specialize into anything. It's just sort of stars, galaxies, anything in between, really.
Mm-hmm. And you search through your data set using humans and machines.
Indeed, yeah.
So the human part of it is a citizen science project. Why are using people particularly good?
Yeah, so we have our sort of citizen science project called Burst from Space MeerKAT, which looks for burst from space from MeerKAT, and it's worked really well. And because our volunteers sort of are able to look through our data in a much more sort of thorough way than, say, I could do by myself, right? So I could set some sort of statistical sort of test to say, if the thing I'm looking for behaves like this or changes like that, that might be one way of finding it. But sort of previous tests have shown that that often doesn't get the best results, and our volunteers can find things that we wouldn't be able to find with those kind of sort of statistical tests alone. And they can basically dig through our data, quickly and very efficiently, and find lots of interesting things that we wouldn't have found otherwise.
Mm-hmm. But obviously, there's whole new generations of telescopes coming out, and one of the big problems I know a lot of astronomers are having is just way too much data. So how are you managing to cope with that, even when you've democratized it to 1,000 people? How are you coping with that?
Yeah, so this is a really good point, right? And the citizen science work we've done so far, it's very quick over the sort of sky area that we've covered with the survey, but it's not infinitely scalable, right? It's as data rates get more intense, and there's we can't expect billions of people looking at our data, even though that would be quite nice. So one of the answers is turning to machine learning techniques. So specifically, I've been using sort of unsupervised anomaly detection techniques that sort of look to find the anomalous and strange and interesting things in your data, and then I can sort of leverage the power of our volunteers to see, are the things that our sort of machine models find to be interesting and anomalous, are those the same things that our volunteers said were interesting variables and transients? So
you're specifically looking for the things that are weird?
Yeah, sort of.
The things you're not expecting.
Exactly,
to find.
yeah. So we phrase it as an anomaly detection type thing because, in a given patch of sky, maybe 1 or 2% of the things in that region of sky will be the interesting variables and transients. So 98% of it is haystack, and only 1 or 2% is needle, right? So that's the kind of thing we're after, yeah.
And have you managed to find anything interesting so far?
Yeah, but the volunteers have done some amazing work. One of my favorite things that they found is this thing called an OH Maser star. So this is not really my area of expertise. So I had to they found this, and I went, oh, that's really cool. Let's find out more about that. And so this is a star that's lived through its sort of middle age and is now sort of at the end of its life, and it has a sort of very big sort of dusty atmosphere around it. and the star is sort of in the middle of that dust, and it sort of it basically creates a laser in space by sort of pumping this sort of gas and dust around it with light. And yeah, so it's a space laser they basically found.
A giant space laser.
Yeah, pretty much. And it shows some really interesting behaviour, which we can't fully explain yet. We've got some ideas, and we might do some more observations to figure that out. And that's been a nice one to get involved with our volunteers. Yeah.
Mm-hmm. So, do you think that one day machines will be able to completely replace humans looking through this kind of data?
Yeah, it's a good point. Certainly, using machine learning techniques and AI and so on is going to become ever more important as data gets more and more. But I don't think it can do everything. There's been some work from collaborators of mine and others that have shown that one of the best things you can do is try and use the machines at the things they're good at. So doing lots of computation, digging through vast amounts of data. But then where the humans really excel is where things get a bit unexpected or serendipitous or into the unknown a little bit. And so there are ways you might be able to prioritize if the machines can do the heavy lifting and then provide sort of a smaller sample of the most interesting candidates in your data, for example. That's what then the volunteers can do. There's been some work that I've seen that really shows that the combination of the two provides a sort of unique window that does better than either technique alone, which I think is really promising.
Mm-hmm. So it's the machine finds the sort of winnows it down, and then you have humans.
Yeah, I think
double check it.
That's a really good way of doing it. Yeah.
And we've been talking a lot about the data that you're looking through,
mm-hmm.
but it's being taken by MeerKAT,
yep.
as you said, which obviously isn't a small animal. So could you tell us what exactly is MeerKAT?
Right. So MeerKAT is a telescope in South Africa, in the Karoo region of South Africa, and so as in all areas of astronomy, it's also an acronym. So the CAT part stands for Karoo Array Telescope because it's an array of telescopes in the Karoo region, and the Meer is Afrikaans for more. So originally the project had 7 dishes, and now they've got more of them, so they decided to call it MeerKAT basically, and by pure coincidence, I'm sure, that also happens to be the name of the small lovable animal in the area. But yeah, it's a fantastic facility that came online only a few years ago, and is really changing the way we can do this kind of science, and that's only going to get more interesting as it sort of scales up to become part of the SKA in due course. Mm-hmm,
which is the Square Kilometre Array.
Yes, yeah.
That's being built across South Africa and Australia.
Mm-hmm.
And so obviously the work that you're doing is specifically designed for these radio telescopes. Could it be applied to other large data sets as well?
Yeah, so some of my work, particularly stuff with the machine learning, is taken a bit of a leaf out of the book of people who search for optical transients. So this kind of anomaly detection techniques used on light curves, how the brightnesses of our sources changes over time. That's something I've taken directly from that work. So it's already being used quite a lot in anticipation for things like the Vera Rubin Observatory, and which is a facility coming online in a few years, maybe, or maybe next year. I can't remember when it's coming online. Which is going to be similarly searching the sky over a long time, looking for interesting transients as well. So very much this kind of technique works in any regime where you've got lots and lots of data and want to find interesting, weird things. Yeah.
Well, it certainly sounds fascinating, and because it does have a citizen science aspect to it. Is it something that people listening at home could possibly get involved with?
Oh yeah, I mean, the more people that get involved, the better. Yeah. Our project is hosted on the Zooniverse website. So if you just maybe Google something like Zooniverse burst from space MeerKAT, you'll be able to find our project. We're currently out of data. Our volunteers are actually sort of they're almost too good in some sense. Like they process the data and tell us all about it in more time than we can prepare new data for them. So we've got more data we want to show to them, which we're hoping to launch next month. So keep eyes peeled for that. That's where it is. Burst from space MeerKAT. Yeah.
Well, so if anybody is at home wants to get involved, that's how you can go about doing that. And thank you very much for talking to us today, Alex.
Absolute pleasure. Thanks for having me.
Thank you for watching, and please subscribe to the channel if you want to get more astronomical news and stargazing tips.